Looks like it's about 10 o'clock. We're getting there. Thank you, everybody, for joining us today for today's coffee break. Today, we're going to be discussing the benefits of humidification for occupant health and comfort. And today, we have Brent Field with more than 20 years experience in the humidification industry. He's the regional sales manager for Condair. And Brent, thank you for being with us today.
All right, thank you, Aaron. Yeah, thanks for letting me join in the coffee break, and thank you for everyone else for listening to my presentation. Yes, we wanted to talk about humidification and its effect on the health and wellness of people. And you've probably seen in articles in trade magazines over the last year or so, how humidification, using the term 40 to 60% RH, helps with our health and wellness and helps to stop the spread of disease and how it makes us feel better. So I thought I'd spend just a little bit of time talking about that today. Next slide. There we go. So I want to start off with just kind of a brief history on buildings that we people have been living in since kind of back to the beginning of time. And really what I wanted to point out here was the relationship between us and the outside environment, and how in the very early days, caveman days and early villages, there was a lot more interaction with the outside world, as far as the outside air that we breathe in, plant matter, animals, how that kind of affects us. And for the most part, that had been a very good thing for us as human beings. But as buildings started becoming more and more secure, they actually protect us better from the cold and the heat and the rain and that sort of thing. It's actually started having somewhat of a negative effect on us. And especially recent days, buildings have become extremely tight with little outside air, windows that don't open and that sort of thing. And while they can help make a comfortable environment, temperature and environment wise, it kind of turning into a negative effect on health. So on this slide here, we kind of show that over time, infectious diseases are actually on the rise. So, and this is really because of we're having less and less interaction with the outside environment. Now, this is a study, one of many that have been done recently, and this one shows the effect of humidification on children in school. And this was a study that was actually done. They took an elementary school. Half of the classrooms in the school were humidified to 45% relative humidity. The other half were just left on their own. And this shows that the airborne particles, the virulence of these viruses, get a lot worse in low humidity conditions, and it affects the absenteeism rate in the people as well. Here we have a slide that kind of shows when people cough and sneeze, we have all these water particles that come out of our bodies and spread. And if we go to the next slide here, it shows that we look at the float time that's affected by different size of these water particles that come out of our bodies. So the particles in general, they come out rather large in size, but if we're in a dry environment, these particles start shrinking and drying up. And that increases the float time. And you see on the very, very small water particles, these can stay in the air, floating in the air for days and days and days. Now, with humidification, these water particles will stay large in size. They'll maintain the structure of these water particles. They'll tend to fall out very quickly, where they can hit the ground, they can be clean, they die out. But the main thing is to get them out of the air. So with unhumidified air, we show there's greater transmission of the aerosols. we all saw in the early days of COVID, actually, everybody was recommending to always be cleaning surfaces, being very good about that. But what it actually does in dry air, it kind of resuspends those particles and they end up back in the air again. And that's where we get sick when we breathe those in. This is a slide here that I like a lot. And this shows along the bottom of this scale, it shows the relative humidity in the space. And on the left side, it shows the infection rates and actually the viability of the infections of the viruses. And at the low end of the range, 10 to 30% range, these viruses stay very active and very virulent. But there's a sweet spot right in the middle we keep talking about called 40 to 60% relative humidity. And in this range, when we can keep the air in our buildings within this range, the infectiousness, the virality of these viruses are at their minimum. So this is another good reason. This slide here is one I like too. So it shows, for people just sitting in a room, this could be your office in the wintertime. You bring in that cold air, you heat it up, dries out very, very dry. It shows what effect that low humidity has on our bodies. And this really affects the way we feel and the way we perform. So we show here it affects our brains, with decreased function and fatigue, respiratory tract. We can breathe in all of these particles are going to enter our body and make us sick much more easily. Dry eyes, we get dermatitis, dry skin, and that sort of thing.
This slide really reminds me a lot of, when I moved to Colorado 18 years ago. People would ask me about the altitude and how that affected me. And really it was the dry climate that I noticed the most, with the itchy skin and the irritated eyes and the dry sinuses. I mean, everything that's on this screen, really kind of hits home.
Yeah, all great points. Mm-hmm. So this is another chart. This is actually part of the Sterling chart that was put together by an ASHRAE committee several years ago. And this was, of course, well before the COVID days. But again, it points out that there's this sweet spot, 40 to 60% relative humidity. And we look at all these factors on the left side. Most all of these factors are much more active the drier the air gets. And also, which is interesting, many of these also become very active and very high humidity. But we have the sweet spot again, 40 to 60% relative humidity. This is really the environment that we want to be in. So we talk about here a building's purpose, and it kind of shows the early days of our buildings. They were, a protective structure to protect us from the outside environment. More recently, a big part of our design has been in energy efficiency. We want to reduce the costs of air conditioning and heating a building. But the thing we really want to now add to this is to optimize the health and comfort of people that spend most of our time indoors. So I want to talk here a little bit about, well, how do we do it? And we in the humidification business, we kind of break our products down into two groups. The first group was what we call isothermal humidifiers, which are steam humidifiers. So we're simply boiling water, making steam. We apply that steam either to the duct, to an air handling unit, or directly to the space. Steam is a really good way to humidify because the steam contains very, very small water particles that absorb into the air very quickly, which is a good thing. That's a good benefit. Kind of the downside to steam is it's expensive to make. It takes a lot of energy, especially if we have larger loads, a lot of energy to create a lot of humidification. So more and more these days, we've been kind of concentrating on our adiabatic series of humidifiers. So rather than boiling water, we're just applying the water through the evaporative process directly to the air. Again, either directly to the space or to an air handler, in some cases to the ductwork. So it's much, much cheaper to make the humidification with the adiabatic series, but there's some challenges there too, because again, water particles now tend to be much larger in size. It's a bit more of a challenge to get all of that absorbed into the air. There's another kind of a side benefit to adiabatic, which is the cooling effect that we get. A little over 1,000 BTUs of cooling for every pound per hour of humidification that we generate. This slide shows our lineup of our steam humidifiers. Again, these are still, I think it's a great choice, for the smaller to medium-sized loads. So we have our 2 electric humidifiers on the far left, our gas humidifiers, which can be a good choice as loads start to get larger. For medium-sized loads, it's a lot less expensive to make the steam rather than using electricity. And then on the right side, our central steam humidifiers. So we use these to utilize existing steam from a building's boiler plant. So we can either directly inject their steam into the duct or the air handler, as long as they're providing us a clean steam. If the boiler is producing kind of a dirty steam, we could use our steam-to-steam heat exchanger to take their dirty steam and turn it into a clean, sterile, atmospheric steam. And this is most of our lineup of our adiabatic systems. And you see we've got a lot of different products included in here now. I'm primarily here just going to talk about the 3 slides on the far left. So these are systems that we use in air handling units. These are very economical to run for large loads. Again, they're going to have the cooling effect, which could be a good benefit if the building has a big cooling demand. But the one on the far left, the ME series, that's our evaporative series. It's a very simple unit. It's a very low cost. It doesn't have the greatest controllability that we have with our other units, but where tightness of control is not that important, it's a good way to go. Next to that is our HP, or high pressure series. And with the high pressure, we actually have a pump module. We're going to supply the water under pressure to nozzles, which are mounted inside the air handler, sprays a very fine mist. This is a good product. They have really good controllability for large humidification loads. We need a fair amount of room, though, in the air handler, 5 to 6 feet, which is kind of a lot for this one to work well. So that's a bit of a challenge on that one. But then we have our DL series, which we call our hybrid humidifier. So with the DL series, we actually have low pressure nozzles, so it's cheaper to run than high pressure. And we spray a fine mist of water, again, into the air handler, and the water that doesn't get absorbed right away into the air comes into contact with our ceramic media. It's a very porous ceramic. If you look at it, it looks kind of like coral. And it's a very interesting material, but then we can evaporate all of the water off of that ceramic, and a smaller footprint within the air handler. Only about 4 feet or so of room is all we need. So this is a product I like a lot. It's also the most hygienic system that we offer. So it's great for labs and medical centers and places like that. And then our next product here, this is another new product for us as we're getting more into more total humidification control. This is our dehumidifier. So we now offer a desiccant dehumidifier. So if we end up with cases like we saw on that Sterling chart, where we have high humidity, we can bring that humidity down, either for people or for processes. A lot of processes require very tight control with not high humidity. So this is kind of our first foray into that product. This is another brand new product here that I like a lot. This is what we call our TE, or tile evaporative humidifier. So this is designed to go up into a ceiling space, in a drop ceiling, where this is a product we really kind of designed for schools. It's great for retrofits. Wherever we have a drop ceiling, this will fit right in. We just supply a water supply to it, a drain away from it. Just 110 volt power is all we need, and it's all self-contained. Comes with its own controls and everything. It's a very quiet running system. It's one that I think that people should take a look at more. It's a very, very cheap way to go. So it's great for, as again, I mentioned, for schools, but we're seeing even more retail, office spaces, things like that as well. And that's my presentation.
Brent, thank you very much. That's it was a lot of information and a lot of great benefits for humidity control. So often we see humidity being added for gym floors or MRI machines, things like that. But a lot of great benefits for the occupants as well. Thank you everybody for joining us, and have a great rest of your day.
All right, thanks everyone.